All right, let's take a look at the review here, and for test one for chapters 1 through 4. So we got some data here. This data is the heights of a population of Douglas fir trees. All right, so the list is over here, and these are rounded. And so the question is what type of data it is. Little twist on this question is these are whole numbers. Yes, there's no decimals attached to them. They're rounded off. The fact, though, is that a Douglas fir tree, a tree that's growing, could be any height. And so since it's any height, that is continuous. So one way to think of that is, if you were to go measure a tree, you could get a tree that's any height. And so that those numbers are continuous. It could be anything between, 0 and however tall a Douglas fir tree can get. I don't know, 50, 60 feet, maybe more. Probably a lot more, actually. Anyways, so N is 37. N is the number of data items. You can count by hand there. In fact, it's not a bad idea to count by hand before you go to your calculator in just a second. There's 37, so when you enter them in your calculator, make sure that there's 37 in your calculator. All right, so using our calculator, we're going to enter all of our data here in our calculator. I'm going to use the app here because I can record it. So we go to Stat, Edit, and we enter all of our data here into list 1. It's a long one, I know. The test won't be that long. There's, looks like 37 numbers. All right, so we're going to go ahead and, in there would be 37, okay? And then we're going to find the mean here by going to Stat, and we're going to go over to Calculate, and 1var stats. And it should already be set up for list 1. So we hit enter, and there's our 1var stats with our 37. All right, and there's our mean. Now, the mean here in this list, X bar is 83. All right, and for our purposes right now, that's going to be the same as mu. Mu means mean of the population. X bar means mean of the sample. So 83.97 will give us what we need there. That's for our mean and our standard deviation. Our sigma is 32.55 there. So we'll use that 32.55. That is a population standard deviation there. All right, sigma. Now let's use some things we know about this here. So we're saying if the data was normally distributed. All right, now notice that if there, what that if means is that we're going to be picturing our bar graph or our bell curve, right? Okay, so normal distribution gives us a symmetric bell curve, something like that. And we'll be using our empirical rule here for answering these questions here. All right, let's look here. We got a copy of our test notes. Make sure you want to have that printed out there. We're going to be looking at this empirical rule part right here. Okay, so the question here on number 5 is predict or what percent would be would the empirical rule predict inside the mean plus 1 standard deviation. All right, so the mean plus 1 standard deviation, that's going up to here and down to here. So that's plus minus. So that's 34% plus 34%. That's 68%. All right, so that would be what percent would be? That'd be 68%. Now we got to find out how many trees would be, that would be. Well, out of the 37, we'd have 37 times 0.68. To find 68%, we're going to take 37 times 0.68. And that gives us 25.16. We'll round off to 25 because we're just talking about how many data items. We don't have partial data items. So there should be 25 trees. All right, we can go count and check. We won't right now, but so if it was normally distributed, what percent would be inside 2 standard deviations? All right, so 2 standard deviations, that's going out to the mean plus 2 standard deviations, the mean minus 2 standard deviations, and that's 95. If you add up these four numbers, you'll get 95%. 95% falls within 2 standard deviations, all right? And another question we might ask again is how many of these trees would that be? That question is not here, but we can multiply 0.95 times 37 to get that. Now, the 5-number summary, if we go back and look at our data here that kind of got cut off in this picture here. Let's go get a picture and we'll get our 5-number summary. All right, here's our 5-number summary. The minimum, quartile 1, median, quartile 2, or quartile 3, sorry, and the max. Remember, median is quartile 2. So we have 18, 69, 80. All right, there we have it. 18, 69, 80, and 91, and 180 is our 5-number summary. Make that 190. Got to learn to read here. All right, so a box plot here. We're going to sketch a box plot. Doesn't have to be perfectly to scale here, but we'll start. We've got a range of 18 to 190. So I don't know. Let's put this down at. How we put this down at 0 to 200? That includes everything, and then we can just split that. That's about 100, and that's about 50, and that's about 150. All right, that's something like that. That's good enough there. All right. Now we could get this from our calculator, but it's probably just as easy to get a reasonable graph like this. We've got 18's about here, and maybe we'll label those important points there. 69 is somewhere right about here, 69. And then 80 is about here. And 91 is about here. And then 190 is all the way out here, 190. All right, so we'll just label those since we're kind of doing this by hand. All right. And so we have a line going through the box. So the box goes from Q1 to Q3. We have a line going out to our max and a line going out to our min. All right, so there's our box plot. Reasonable graph of it. Assimilation. So our outliers, well, now we got to find our IQR. So our IQR is 91 minus 69, which is, let's see, 22. So 22, so we need to find our fences. Our lower fence is, let's see, the Q1, which is 69, minus 1.5 times 22. And 1.5 times 22 is 33. And so if we subtract that from 69, we get 36. The upper fence is going to be added to 91 Q3. We're going to add 1.5 times 22. All right, so that's 33 plus that, so that's 124. And so now we can look for outliers here. So we go to our list and we see what numbers on our list are less than 36. Do we have any? We do. We have 18 and 28. So 18 and 28 are the outliers. So outliers are 18 and 28. Are there any above 124? And there are. There's these three here. 155, 171, 190, 155, and those are feet. All right, so back on our graph here, we should probably label those. We do have, we can put a little X or a star at 18 and 28. We have some outliers there, and we have one at 190. We have one at 171, somewhere about here, and one at 155 about here. All right, so those are outliers. All right, so we need to make a frequency diagram with 6 categories here. So we find our range, 191 minus 18, and that's going to give us 173. Now, we need a multiple of 6 that's close to that. I'm going to keep things simple. How about we go 180 divided by 6, and that gives us 30. So that makes each category have a width of 30. All right? So that will get us. So if we start at 18, then our next one will be 48. And our next one will be 78. Our next one will be 108. And our next one will be, yeah, I'm just adding 30 every time. You see that? And that's 6 categories there. And our next one would be 198, but we're going to stop at 197. See how that works? So we don't need that category there. And so, whoops. So these will go up to, but not touch the other one, the next category. All right, so I'm subtracting 167. There we go. All right. So now we just need to count how many are in that range. All right. So from 18 to 47, we take a look. 18 to 47, that cuts us off there, and there are 3. All right, so there's 3, and I'm going to continue counting like that. I'll pause it so I don't make you dizzy doing this. All right, so this is our x values and our frequency. We should get something like that. All right, now you can break them into different numbers on the left, the x values over here, but there needs to be 6 of them. That's the key. All right, so the question is this symmetrical or skewed right? Well, notice most of the numbers are over here in the lower section. So if we were to make a histogram out of that, there'd be a bunch here, and there would be not very many here. Okay, so this would be skewed right, because that tail would be off to the right. Okay, there's outliers. There's 4 real tall trees on the right. All right. So let's look at the next page and see how that goes. Oh, I forgot there was a table here. I'll copy that into the table. All right, so for this part here, we're going to do this work by hand. Notice there's a smaller list of numbers here, all right? So we want to be able to graph these here. We've got a range going up to 62. So I'm going to sketch this by hand. 10, 20, 30, 40, 50, 60. So there's 60. And then we're going up to 115 here. So I'm going to go up by a little larger numbers. Maybe we'll go up by 20s here. 20, 40, 60, 80, 100, and 120. Okay. All right, so this will be age. Let's get some labels. And this will be blood pressure. All right. And so let's graph this. 22, we go right 22 and up 88. Okay, about right here. Right 28 and up 90. Right 35 and up 95. And right 44, up 110. Up about here. Oops, a little, not quite as high. 110, up 62, and up 115. Something about like that, all right? We can check them on your calculator, all right? You can enter those into list 1, list 2 in your calculator, and you should get something about like that. Now, to get a line of best fit here, line of best fit is that line that kind of goes right through it there. All right, let's work this out, all right? So, but using ages 28 and 62. So 28 and 62. So these are the points 28, comma 90, and 62, comma 115. So first thing we got to do is we got to find the slope. The slope, we're going to take 115 minus 90 all over. So we subtract the y's, we subtract the x's. 62 minus 28. And that gives us about 0.735. Okay, so now what we need to do is we need to plug these into our equation, y equals mx plus b. And we're going to get this. So y equals mx plus b. So we're going to plug in one of these points. Let's plug in the point 28 and 90. So 90 is the y. And our slope we just found was 0.735. And the x is 28. And we need to find the b. So we can do some algebra, multiply this, and then subtract it from both sides. And you're going to get b is about 69.42. So that gives us our equation. Y equals 0.735x plus 69.42. Okay? Now, another thing we want to be ready for is interpreting that slope. What does that slope mean? All right, so the question is not there, but make sure that you know that the slope is a ratio of the y over the x. So this is the change in blood pressure per age, all right? So blood pressure is rising. So her pressure is rising at 0.735 points per year, okay? All right. So now we can find the x bar by averaging these all out. Add them and divide by 5, and we get about an x bar of 38.2. Right, x being the first coordinate. Now we can add up all the y's and divide by 5. And that's going to give us an x bar, a y bar actually, of 99.6. All right. Now we need to find the standard deviation and for the x and the standard deviation for y. And we need to be ready to do that by hand. All right. So we're going to take the standard deviation for the x column first. And so what we need to do is we need to make a table. And so we need to have our x's. We're going to need to subtract the mean, x minus x bar. We're going to need to square that. And then we'll need to get a grand total of that. So we've got our list of numbers. Now we're going to subtract x bar, which is 38.2. And we'll calculate each of those. And you can use your list for this. We did a little bit of that the other day. And so if you want to use that to help crank out a bunch of this, you can. Or you can do them one by one. Take each number and subtract the mean from it. And we should get 23.8. And then we're going to take each of these numbers and we're going to square them. Okay, 262 and 104 and 10.24. All right, so it takes a little bit of work. Again, if you want to use your list, if you've got that down, that can be helpful. If not, just do them one by one. Okay, we're squaring the second column to get to the third column. And all right, something like that. And now we need to total all these, all of that last column. So total gives us 976.8. And now looking at our definition, we need to take that and we need to divide it. Now we're finding the Sx, which is the sample standard deviation. So we need to take that number there. And we need the square root of that total. And we need to divide that by n minus 1. And so that's 5 minus 1, which is obviously 4. So use your calculator for that. Just crank it out. And we get 15.63. Okay. That's the idea there. All right, let's try another one for y here. So our standard deviations for y, we're going to make another table. And we'll copy the numbers from up here, 88, 90, 95. 88, 90, 95, and then 110 and 115. Now our mean is 99.6. So y bar is 99.6. We're going to subtract that from each of these in the y list. So subtract them one by one, and we get that list there, and then we're going to square them. So take this column here, square them to get this column over here. And just takes a little bit of work. But we should get these numbers here. And then once we've got that list, we need to calculate our total. So we'll have to add that all up. And it looks like we get 593.2. Okay, so that was the hard work. Now we got to square that using our formula. So the standard deviation for the y's is the square root of 593.2 divided by, again, there's 5 minus 1, n minus 1. Check out the formula there. It says n minus 1. And so we get a standard deviation of 12.18. All right. So that gives us the spread. Remember, standard deviation tells us the spread of each of these numbers here. Okay. All right, cruising along, we need the z-score for a blood pressure of 110. Okay. So remember our z-score. The formula for z would be, we're going to take that variable y, subtract the mean, and divide it by the standard deviation. All right, so that y value is 110. Subtracting the standard deviation for that list, we're calling it the y's. Whoops, sorry, the mean, not the standard deviation. So the mean, what was the mean there? 99.6. And divide that by the standard deviation, which was 12.8. And let your calculator do the work there. Make sure you use parentheses for the top. And that gives us 0.8125. And remember, that's the number of standard deviations away from the mean. So almost one standard deviation away from the mean. Above the mean is that number. All right. Okay, so we're going to use our next one, 19. We're going to use our calculator. So we're going to go to, you've got all those in your list. We're going to go to Stat, Calculate, and we do our linear regression, Lin Reg. All right. And the A and the B that it gives you are your slope and your y-intercept. Y equals 0.74x plus 71.15. That's our y hat. The correlation coefficient is this number r, and it's 0.95558, it looks like. Okay, which means that this is a good fit. Okay, or it is a strong correlation because it's close to 1. That means that the line is very close to the points. A couple more here. now we're going to go ahead and use that equation to predict if we have 70 years of age. Well, the age, to predict the blood pressure, that is. So the age is the x value. So we're going to put 70 in for x and calculate the blood pressure. So the predicted blood pressure is 122.95. All right, do we have units for that? We don't really have units here. They don't give us units, so whatever the units were on blood pressure, we'd have that, but we're not given that, so there's our answer there. Okay, and then last but not least, let's use that to predict the age that we would need if we had a blood pressure of 97. So the blood pressure is the y value, and so we have 0.74x plus 71.15. Whoops, 5. And we just need to use our algebra to solve that. So we're going to subtract, and we're going to show our steps here. You can use your calculator to do the calculations, but you need to show your work as you do this. And we'll round it off a bit here. And 0.74x, and now we're going to divide by 0.74. So let's take that number and divide by 0.74, and we get x equals about 34.93. Okay, so the age in years is about 34. So a person with a blood pressure of 97 would be expected to be, or should be, about 34.9 years old, okay? Should be, we could say almost 35 or 34.9 years old. Okay, that's the idea. All right, so the regression equation gives us a way to predict one way or the other. All right, so hope that helps, and keep working hard, and you're going to do great.